Welcome to our today's class. Today we focus on rules of differentiation. And we focus on rule number 4 and rule number 5, product rule and quotient rule. A product rule basically tells us if you have two functions, u and v, which are differentiable functions of x, u and v, and differentiable functions of x, then the dy dx of the product of u and v is given by that formula there. So an example here is that if you have y is equals to 12 plus x into bracket 3 plus x squared, you take the first part here to represent u. So u is that part. So du dx is equals to 1 because the derivative of a constant is 0, and then x here is just 1 because when you differentiate, as I had said last time, it is 1. So when you finish that, you take the other part here, which becomes your v. So v is equals to 3 plus x squared. If you differentiate, the derivative of a constant is 0, x squared becomes 2x. So this is dv dx. So you start to replace them in this formula. What is your u? Your u as a function is 12 plus x. And what is your dv dx? dv dx is 2 into x plus your v. v is 3 plus x as the function into bracket. du dx is 1. So if you work it out, it will give you 24x plus 2x squared plus 3 plus x squared. If you simplify, it becomes 24x plus 3x squared plus 3. It is exactly what has been worked out for you here. Look at another one before we forget about it. Now, the first part, we let it to be our u. So the first part, the first function is 2 minus x. So your du dx is equals to 2 is a constant, then x, so I get minus 1. The second part, I let it to be v, this other part, 1 plus 3x squared. So this is dv dx being equals to 6x, because this is a constant, which is 0. So this power comes in front to give me 6, and then I reduce by 1 to give me 6x. So I apply the formula now. Dy dx, the formula tells me it is, the formula says it is u dv dx, then v du dx. So when you replace here, you get u. My u is 2 minus x. And what is dv dx? dv dx is 6x. Then I had v. What is v? v is 1 plus 3x squared. Then this is what I multiply with du dx, which is actually minus 1. So when you simplify that, it gives you 12x minus 6x squared plus, not plus, but minus, because of the minus 1 outside, minus 1, then minus 3x squared. When you collect the like terms, you get 12 minus 9, 12x minus 9x squared minus 1. So that is the answer. I go to the quotient rule. Look at this. So the quotient rule, there are two functions, u and v. They are functions of x and they are both differentiable with respect to x. So when you look at their division, then the dx of them will be given by that. Let me pick a simple example, that y is equals to x squared over 1 plus x. In this case, my u becomes the numerator. U is equals to x squared, meaning that my du dx is basically 2x. Then my v is the denominator, 1 plus x. When you differentiate, you get dv dx is equals to 1. Then I replace that in this big formula here. When I replace this in this big formula, my v as a function is 1 plus x. And it is being multiplied by du dx, which is 2x. Plus, sorry, minus u. My u as a function is x squared. Then dv dx is 1 here. So when you simplify, but before you simplify, divide by v squared. V squared is 1 plus x. So this we square. So simplify. The top becomes 2x plus 2x squared minus x squared over 1 plus x everything squared. So this simplifies to collect the like terms. It will be 2x plus x squared over 1 plus x everything squared. If you are to simplify, you would factor out the x and then you remain with x plus that. But let me show you. If you were to simplify, we would factor out the x into 2 plus x over what we have, 1 plus x everything squared. But it suffices to be left at that level. There's another one here which already I've worked out the answer for you. Simple. The function looks like this. You're required to find dy dx. So the top, this top one here becomes our u there. So when you differentiate, it gives you 1 because already this is a constant. Then the numerator is here. The denominator is there, so that becomes my v. When you differentiate again, you get a 1. So you again replace in the formula. If you replace in the formula, you replace them like this. When you solve, simplify, it reduces to that one. Got this? If I solve this one for you, this is the top. We let the top to be x cubed plus 2. So you look for du dx. Du dx in this case will be 3x squared. This 2 disappears. Your v is the denominator, x squared minus 1, meaning that dv dx is equals to 2x. How does our formula look like? Dy dx, our formula was v du dx minus u dv dx, everything divided by v squared. Let's replace. If you replace here, this becomes v is x squared minus 1. This multiplied with dv du dx, which is 3x squared, minus u. My u as a function is x cubed plus 2. And then from there, my dv dx is 2x. Then everything I will divide with v. So I will divide with x squared minus 1, everything squared. Let's see whether we can break down the numerator. I multiply, I'll get 3x power 4, then minus 3x squared, then minus 2x power 4, minus 4x. Everything is divided by x squared minus 1, everything squared. If you are to further simplify that, top, I'll get, if I collect the like terms together, the top I'll get x power 4, because the 3 and the 2 will leave me with that. Then minus 3x squared, then minus 4x, then everything divided by x squared minus 1, all that squared, that being the answer. Thank you very much. See you next time.